Hi, this is me, Assis Ariel. Today we are going to present our second assignment for COIT 20260. Uh, Me with my friend Rajesh and Bikram are going to present this project. Let's start with a demonstration first. For this project, we created an student records management system, and which is hosted on AWS Cloud. For this, we created an EC2 instance, and we create a database for this student record management system, and our API backend is running on EC2 instance, and the database is connected with EC2 instance. Uh, uh, and we also implemented some load balancing and auto scaling group for better performance. We also implemented some security rule, which is inbound and outbound rule, that is SSS, HTTP, HTTPS, and some outbound rule too. Uh, this is our EC2 instance, and we also implemented a load balancer. Yeah. This is our load balancer. Uh, yeah, and I already run the backend server, and the HTTPD is already enabled. I started. Let's see. Uh, our system is working or not. This is our user view for student record management system. It's look like a simple website. Here we can add a new student, view student records, and also delete and edit student data. Let's check if the system is working or not. I'm going to add a new student record. The name is um, student name. Yes, name at gmail.com, address Essendon, city Sydney, NSW, yeah, Australia, and put some phone number 0404 and save this record. Yeah, the student record is saved. And also we can view the student record. Yeah, this is our, we recently added a student data. We can edit this data from directly here. Now I'm going to change the city to Melbourne and update. Yeah, update is successful. Also, we can delete directly from the here. Delete. Yeah, the student record is deleted. Also, we can delete the student record from this field. Here, I'm going to delete this 7 ID student. 7 delete. Okay, done. Deleted. Yeah, yeah, deleted. That's our system, and it is quick, responsive, and very scalable. And we also implemented load balancing, and this system is running from 3 availability zone and 6 subnets, so the system is running smoothly. uh, Here is the system. Now I'm going to show you our mm, backend API code. This is our backend API code, and I'm going to show you front end code. Yeah, this is our front end code. Now the next part for this documentation part and other detail are going to present by my team member Rajesh and Manoj, or Bikram Grum. Rajesh and Bikram Grum. Thank you.
Hi everyone, my name is Bikram Gurung. Our project is about moving the university's student record system to AWS Cloud. The goal is to make the system faster, more reliable, and able to handle thousands of users during the busy admission periods. This system let staff create, read, update, and delete the student records. Our design makes sure these actions work smoothly without delays. So, architecture's overview. Our design has four main layers, that is the front-end layer, data layer, application layer, and the security and management layer. So, first, the front-end layer. We use CloudFront to make the website load faster and make application load balanced to share user traffic across several servers. This servers runs in an auto scale group, which means more servers can be added automatically if demand increase and remove when the demand is low. Second, the application layer. Here we run a Node.js application that handles all the student record requests. Third, the data layer. We use Amazon RDS with MySQL as the database. It is set up across two availability zones for higher availability, and it is kept in private subnets, so it can be accessed directly from the internet. Finally, the security and management layer. We use IAM roles and security groups to control access. System manager parameter stores to keep passwords safe, and CloudWatch to monitor the system and send alert. This setup gives us secure, scalable and cost-effective solution. So now I will hand over to my friend Rajesh to discuss about next topics. Thank you.
Hi, my name is Rajesh Khodka, and in this section of our presentation, I will be providing an overview of our proposed AWS architecture for XYZ University. I will walk you through the core design of our solution, explaining how we have used AWS services to meet the key requirement of high availability, scalability, security, and cost optimization. Our solution is built on several core AWS services: user traffic first, it's Amazon CloudFront, our content delivery network to cache static content and reduce latency globally. It then routes to an application load balancer which distributes traffic across our fleet of EC2 instances hosting the web application. These instances reside in an auto-scaling group spread across three availability zones. This group automatically scales the number of servers up or down based on real-time demand, ensuring we can handle peak admissions traffic while optimizing costs. For the database, we chose Amazon RDS for MySQL configured with a multi-agent deployment. This means a synchronous standby replica is maintained in a separate data center. If the primary database fails, RDS automatically fails over to the standby, typically within a minute, ensuring high availability and data durability. Now on to security, which we implemented in layers. Our network is partitioned using a VPC with public and private subnets. The web servers are in public subnets, but the RDS database is completely isolated in a private subnet with no direct internet access, meeting the critical requirement of securing the database. Access is controlled by security groups acting as strict firewalls. Furthermore, to eliminate hard-coded credentials, database connection strings are securely stored and retrieved using AWS Systems Manager Parameter Store, which encrypts the data at rest. Finally, this design is inherently cost optimized. Auto scaling prevents over provisioning. We leverage pricing models like reserved instances for baseline load, and storage auto scaling ensures we only pay for the capacity we actually use. In summary, this architecture meets all the university's requirements. It is load balanced, highly available, secure, scalable, and cost effective, providing a robust foundation for the student records application. Thank you.
Thank you, Rajesh and Bikram. Now I am going to show AWS architecture design. The system is working like this type of a design. First of all, at the top, internet user and Amazon CloudFront, and then application load balancer. There are three availability zone, and the three availability zone are installed on VPC private subnet. There are six VPC private subnets and some AWS services like auto scaling group, security group, VPC, and subnet. IAM roles are implemented on our system. So this is the overall AWS architecture diagram of our student record management system. And now I am going to conclude this system. The proposed AWS architecture for the student record management system successfully address all designs requirements through a well-considered combination of AWS services. The solution provides a functionally scalable and highly available, cost-optimized, secure, and highly performing system that meets the needs of educational institution for managing student record effectively. The architecture leverages AWS best practice and managed service to reduce operational overhead while maintaining high standard of reliability and security. The implementation can be further enhanced with additional features such as automatic backup, disaster recovery procedure, and advanced monitoring as institutional requirement evolves. And this is our overall systems. And thank you for listening us, watching us. Thank you so much. Have a good day.